So now let's go ahead and solve for standard deviation. Now I've written the formula down, however we need to do the standard deviation twice because we are not only solving for the EX squared, but we are also solving for the EY squared. And if you remember from earlier in our R formula, we need the standard deviation from X and the standard deviation from Y. So we're going to do this whole process twice. Okay, so since we have all of these values, let's just go ahead and plug that number in. So let's start with X. So we have the EX squared value of 120. We're going to put that over our N value of 5. And then we are going to subtract that from the mean of X, which is 4.4. And then that's going to be squared. And the entire thing is going to be square root. So why don't we go ahead and do the exponent first. So we'll have 120 over 5 minus 4.4 squared, which 4.4 squared is 19.36. Okay, and then we'll just keep solving down that. So 120 divided by 5 is 24 minus 19.36, and then that goes in the square root. Okay, so 24 minus 19.36 is going to give us 4.64. That is square rooted. And then when you solve for the square root of that, you get 2.15. Okay, and so that is our standard deviation for X. So let's go ahead and write that up here. We've got 2.15. Okay, now let's find the standard deviation for Y. So we're going to do that whole thing all over again. So we've got 43 divided by 5 minus our mean for Y, which is 2.2, and we are going to square that. Put all of that under square root. Okay, so then we have 43 divided by 5 minus 2.2 squared is going to give us 4.84. Square root all of that. And then keep solving. So 43 divided by 5 is going to give us 8.6 minus 4.84. And then 8.6 minus 4.84 is going to give us 3.76. Then when we solve for the square root of that, that is going to give us 1.94. Okay, so now we have our 1.94, our standard deviation X and Y, and it looks like the only thing that we have left now is to solve for our R value. The last part of the Pearson R is finding the R value. So I went ahead and wrote the formula down here. So all that we have to do is take the numbers from our sheet here and plug those right into our formula and then just solve for those. So let's go ahead and do that. We've got 67 over our N value of 5. We are going to subtract the mx value of 4.4 times my, which is 2.2. And then that is all going to go over the SDX, which is 2.15. And then SDY, which is 1.94. Okay, let's go ahead and get that solved. So 67 divided by 5 is going to give us 13.4. And then we're going to multiply these two numbers together. So 4.4 times 2.2 is going to give us 9.68. And then these two numbers multiplied together, 2.15 and 1.94, that's going to give us 4.17. Okay, so we just keep solving that. So 13.4 minus 9.68 is going to give us 3.72 over 4.17. We're going to divide that out, and that is going to give us 0.89. So our R value is going to be 0.89. Sorry, that looked like a 10. There we go, 0.89. And there it is. There's all of our information on our sheet. So the last part that we have to do is see if we can reject HL. Now that we've calculated our R value, let's go ahead and see if there is a significant difference between the time spent online and number of shoes bought. So let's go ahead and plug in our values here. We have our R value here of 0.89. Now we need to put our degrees of freedom here, which I've written down. It is 3 for each of those. So when you look at your table here, we have got a degree of freedom of 3. So the 0.05 for 3 is 0.878. And then for the 0.01 is 0.959. Okay, now let's go ahead and see if we can reject HO. Now there's 2 different ways that you can do this. Well, there's actually a bunch of different ways that you can do this, so I'll show you a few. So the way that I do it is you take your R value here. So you have 0.89. Is that greater than this 0.05 value here of 0.878? So is 0.89 bigger than 0.878? Yes, it is. Is 0.89 greater than 0.959? No, it is not. So since it is greater than this value here, and this value is at the 0.05 level, that means that, yes, we can reject P less than 0.05. Awesome. Okay, so another way to do that is, let's go ahead and take these and mark these on a graph. Okay, so we will go ahead and do this here. So we'll put this as 0.878, and then we'll put this one up here of 0.959. Okay, so this area here, the blue area, this is going to be reject at 0.01. Then this area here in green is going to be reject at 0.05. And then this area, all of this in the pink, all of that, that is accept. Okay, so now that we have that, let's go ahead and plot our R value, which was 0.89. So that's going to put it right here. 0.89. That is within the reject at 0.05 area. So you can do the same thing on a number line if you want, the same exact thing. So you can have your 0.878 and your 0.959, and then anything over here is 0.01. And anything over here is 0.05. And then anything here is accept. And then you go ahead and do the same thing. So you're going to take your R value of 0.89. You're going to put that right here, 0.89. And that is within the 0.05 range. And so you reject at 0.05. Congratulations, you just did a Pearson R.